In this video, I'm going to go over how to solve a couple of problems that are related to Unit 3 using the graphics calculator, so the TI-Nspire CAS Calculator. If you haven't got this calculator, I apologize in advance. This probably isn't going to help you too much, but there's a bunch of resources all through the internet that should be able to help you with the type of calculator that you have. The first question that we're going to do is question 7. We're finding the exact area between the curve and the x-axis between x equals 0 and x equals pi on 2 for this trig function here. So first thing I'm going to do is I'm going to click on New and I'm going to click on Graphs. So once I've typed in the graph that I want, I click on Enter. Okay, so this gives me my graph. Now I want to find the region bounded by the curve between 0 and pi on 2. So what I'm going to now do is I'm going to click on Menu. I'm going to go Graph Entry Edit, and I want to add 2 lines. I want to add a line that is at x equals 0, or essentially the y-axis, and then I also want to add another line when x equals pi on 2. A relation is if I just want to add a straight line that is associated with the x-axis. So I'm going to write x equals 0, which will just add a line on my y-axis. Then I'm going to do the same thing. So I'm going to click on Menu, Graph, Entry, Edit, Relation, and I'm going to type in pi on 2. So I can click this pi symbol over here, pi divided by 2. Whoops, I should have put an x in here. So x equals pi divided by 2. Enter. So now I've got my 2 intervals. What I'm going to just do is I'm going to click on this. I'm going to hold, and then that should give me the option to move this out of the way. So if I click and hold for a second, that should give me the option to move it away because I don't need that anymore. I don't need those in that position. So realistically, what we're trying to do, if we're finding the exact area, we're finding this region in here plus this region here. So I'm going to have to find, what that means is I'm going to have to find the integral from x equals 0 to, it appears that this is probably x equals 1. And then what I'm going to do is I'm going to find a second integral from this current point, from x equals 1 to pi on 2. Once I've got those 2 areas, I'm going to add them together, but I'm going to add the absolute value of this smaller area that's below the x-axis. The reason why I'm going to add the absolute value of that is because that's going to change it to a positive. So long story short, all I'm really doing is I'm just ignoring the negative sign of this area and then adding the 2 areas together. So now what I'm going to do is I'm going to find out if this actually is 1. Because it's a tree graph, maybe it isn't 1. It looks like it is exactly 1, but it might not be. So I need to find out exactly what that point is. So I'm going to click on Analyze Graph, and I'm going to click on 0. That tells me where my x-intercepts are. So I'm going to click my graph. This is the graph I want. And then I'm going to click my lower bound, and then I'm going to scroll across to my upper bound. And luckily we did that, because if I had have assumed that x was equal to 0, I would have been incorrect in this case. So the x coordinate of this point here is actually 0.9553 something, something, something. So now when I integrate, I want to start at the y-axis, and I'm going to drag my integration line to this point. So I'm going to click on Menu, I'm going to click on Analyze Graph, and then I'm going to go across to Integral because I want to integrate. I click my graph, which is going to be this graph here. Now I've got to pick my lower bound. I want to make sure that when I'm selecting this, that my line is directly on this. I want to make sure it's directly on the y-axis. That appears to be directly on the y-axis. I'm going to click now, and I'm going to drag this across until my intersecting point. So that gives me the area that is from 0 to x equals 0.95. Now I'm going to do the exact same process again, but for the area underneath. So I'm going to click on Menu, click on Analyze Graph. I'm going to click on Integral, and then I'm going to click on the graph that I want to integrate, which is this. And then I'm going to click on that point. It's really important. It actually gives me an option. So like if you hover close enough to a point, it gives you the option to just click that point, which is useful. Now we're going to go across and notice that it even gives me an option to choose the intersection point, which is the point that I want. So I'm going to click on that. And then we've got 0.798, etc., etc. Okay, so now it's just a matter of adding these two values together, but ignoring the negative sign of this, and then that will give me the exact area between the curve of this function here within the domain of 0 and x equals pi on 2. Now we're going to answer question 8, which is to find the area bound by the curve y equals x cubed plus x squared minus 2x and the x-axis. So first thing I need to do is I need to graph my function, which I've done here. Now what I'm going to do is I'm going to find all of these intercepts. These intercepts are going to be important to us because essentially, like this looks like it's going to be 0. I kind of know that it is 0 just by looking at this function, because if we let x equal 0, then y is going to be equal to 0 as well. But let's just prove it going through the skills on the graphics calculator. So I'm going to find my 0 points. So first one, we've got -2 and 0. Second one is going to be 0, 0. But let's just prove that. So upper bound, lower bound, 0, 0. And then we've got our third x-intercept, which looks like it's going to be 1, 0. Yep. All right. So now what I'm going to do is I'm going to go to analyze graph. I want to find the integral. I'm going to click on this intersecting point and I'm going to click on that. So we're told that that's 2.66666. And then if I just go and do the same thing for the next part of this graph, which I'm going to get a negative value for, but because we're adding these two areas, I'm just going to change it to a positive value. Okay, so we've got these two values that we're going to add together. Another way I could do this question is I could solve this question in the calculator section. So in this case, I'm going to add calculator and I'm going to click on menu. Menu is the way forward, escape is the way back. So these two buttons you're going to be hitting a lot. We're going to go calculus. We are going to click on integral. We're going to type in -2 and 0. The reason why we're typing in -2 and 0 is because this is going to give us the first section that was above the x-axis. Then we're going to add the section below the x-axis, which was from 0 to 1. So now I've just got to enter in the function that I had. So there we go. I can hit enter and that gives me 8/3. So which is 2.66666 recurring. Now I'm going to do the same thing. What I can do though, instead of just rewriting this entire function, I can copy this. So I can select this all and I can actually just click Control C to copy. Then I'm going to go to the next line and I'm going to click Control V, which is essentially what you would do in Microsoft Word and if you wanted to copy and paste something. So now I've got basically the exact same thing. I've just got to make this top interval 1 and I've got to make this equal to 0. And then I'm going to hit enter and then that gives me the second value, which I'm going to just ignore the negative here because I'm going to add these two areas together. What I could do now, if I wanted to just do this on a calculator, I could do 8/3 plus 5/12, enter, and that gives me the exact value of the area bounded by the curve and the x-axis of this function here. Now we're going to do question 9, which is to determine the exact area between the curve of y equals 1 on x, the x-axis, and from the points where x equals 1/2 and x equals 2. So I've sketched my graph of y equals 1 on x. Now I'm just going to add x equals 1/2 and x equals 2 as relations. So not functions, but relations. Here I could write 1/2 or 0.5, it doesn't matter. Okay, so what we're looking to find is this area bounded in here now. So if we wanted to find the area of this, since we know that this is above the x-axis, realistically, we could just integrate normally. So we could just find the integral of this function bounded by x equals 0.5 and x equals 2. So if we're using the calculator feature, we're going to click on menu, we're going to click on calculus, we're going to click on integral, we're going to go from 0.5 to 2 of 1 on x dx with respect to x. So we would just have to leave our answer like that. And the reason for that, the reason why we don't really get a clear answer is because if we integrate 1 on x, we're going to get the natural log of x. So our final answer, if we were integrating this algebraically, we'd end up with the natural log of 2 minus the natural log of 0.5, and that's not going to give us a neat answer. It's going to give us some nasty decimal, but you can see that it's the same value. Okay, so for the last part of this, now we're going to find the area bounded by the curves f equals x and g of x equals x squared minus 2. So first thing we're going to do is just enter those in. Okay, so if we just go back to the question, we want to find the area bound by the curves. So that's the information it gives us. So what that means is to find the area bounded by the curves, we've got to find the intersecting points first. We've got to find this point of intersection and this point of intersection, and then we're going to find the bounded area between here and here. So step 1 for this question is to find the intersecting points. So we've found one of our intersecting points. We're going to find the other intersecting point by doing the exact same thing. So we're going to click on Analyze Graph and then 4 for intersection. Okay, we've got our points. Now, once we've got to Analyze Graph, instead of clicking Integral like we normally would, now we're going to click on Bounded Area. And the reason why this function is really good is we can use this for functions that are really, really messy and complicated. So right now, if I just click escape and escape again, we're not looking at functions that are too bad here. Once again, this is another situation. It would probably be almost quicker doing this algebraically because they're pretty simple functions to be dealing with. But if function 1 was something messy like y equals 4e to the negative 2.5x minus 6 of that, or something nasty, and then this was something nasty too, this skill is going to be super useful. So to find the bounded area, I go Analyze Graph. Instead of Integral, I'm going to click on Bounded Area. Now I get to click my lower bound and my upper bound. My lower bound is obviously going to be this point. And because we've found an intersecting point, it gives us an option to just click that point straight away. And then now we're going to go to our upper bound, which is this point. And that tells us that the area is 4.5 units. That's it for this video, guys. Hope you found it helpful. All of these skills are going to be pretty useful going into IA2 for your Unit 3 methods exams.